Hi class, this lesson is going to deal with operations with the function as well as domain. Okay, so let's just talk about notation real fast. Remember, if it says f of x plus g of x, since they're both of x, you can write that as f plus g, okay, of the function x. So you have to make sure that you say the word of right here. It's not times x. Okay, same thing with subtraction. F of x minus g of x could be written as f minus g, and they're both of variable x. We could write multiplication, f times g of x, or f divided by g of x. Okay, so how do you do the domain after you do some operations? Okay, for all of them, you must consider. Okay, should I state the domain for f or for g? And the answer is both. Must consider domains of both f of x, okay, and g of x. You can't just state the domain for f. You have to do f and g, okay? And list the more restrictive. List the more restrictive. So what that means, if f only allows positive numbers, but g will allow everyone, well, then you have to listen to f, because he only works with positives. I know g, you will use any number, negatives included, but f won't work. Okay, so that's why you list the more restrictive. Now, I'm going to take a different color pen because something interesting happens here. Okay, when g of x gets put into the denominator, okay, another special case appears. Since the function got moved into the denominator, your g of x function cannot equal 0. So that might add on another restriction since you put them in the denominator. Okay? All right, here's an example. F of x is this rational function, and g of x is this rational function. Nice. Okay, find the following and state the domain. Okay, so the first thing I'm going to do, it makes it really easy sometimes if I list the domains for f and g right underneath it. So for f, your domain is all rails except when you're in the denominator, you cannot equal 0. So then you minus the 2. X cannot equal negative 2. So f will allow all numbers except negative 2. And then how about the domain for g? He will allow all real numbers except, okay, denominators cannot equal 0. X cannot equal 1. Okay, so f will not work with the number negative 2, and g will not allow the number 1 to go in. Okay, so that's handy to have by. All right, let's go ahead and do our operations. So f of x minus g of x is going to be 1 over x plus 2 minus the fraction x over x minus 1. Okay? And then we have to remember, when adding and subtracting fractions, we should always make common denominators. Okay, and so these are quantities here. We have to keep the quantity with parentheses just the way he is. So this second fraction is going to need to get multiplied, top and bottom, by the quantity x plus 2. What you do to the top, you do to the bottom. Okay, now this denominator has both of the quantities, and I need to make sure that this denominator looks the same. So what you do to the top, you do to the bottom. Okay, and I am going to look for that written 2 times. You don't just write it once. You write it in the numerator as well as the denominator. Okay, so now what are we going to do? I am going to leave the denominator in factored form. Okay, do you know why I do that? I want to very easily see the denominator because that makes the domain part easier. Okay, so let's just write a little note here. Leave denominator in factored form. In factored form. It makes the domain part easier. But the numerator needs to get distributed. And then the like terms added. So the first numerator is just x minus 1. Be careful here. We're distributing a negative x. So it's going to be minus x squared minus 2x. So you distribute the numerator so you could collect your like terms. And I'm going to go ahead and write this in descending order here. Negative x squared minus x minus 1. And then the denominator was that stuff right there. Okay? And it's always a good idea to look to see if this can get factored. If it could get factored, I might be able to cancel one out, but I don't think it does. Okay, so there is the function f minus g of x, and now we have to state the domain. Okay, and remember, we have to consider f, we have to consider g, and then we're going to look at the new function as well. Okay, so f says do not use negative 2. G says don't use a 1. Okay, and then here I notice don't use a 1, don't use negative 2, don't use 1, don't use negative 2. Okay, so I think the domain is all reals except, comma, x cannot equal 1 or negative 2. So people ask me, where am I supposed to look for domain? Do I look in the beginning, the middle, or the end? And the answer is you look everywhere. You grab all those restrictions that you need. Okay, I'm going to go ahead here and do the dividing one. This one gets interesting. Okay, so we're going to write a divide problem. Okay, so let's put a big fat divide bar, big fat one. Okay, in the numerator, we're going to write our f function, and then I'm going to divide by the g function. Okay, and I don't know about you, but a quadruple decker fraction is not something that I like to work with. Okay, so I'm going to give you a hint here. Okay, here's a hint. We're going to go old school. We're going to go old school, okay? What does that mean? What does that mean, okay? We're not going to write this massive divide sign. So let's write our f of x, 1 over x plus 2. Okay, and when I mean old school, instead of this big var, I'm going to write the divide sign right there. Okay, write that divide sign that you used to use when you were in grade school. Here's the f function. Divide by the g function. Okay, so this is f of x, and this is divided by the g of x. Now, what do you do when you have an old school divide sign like that with fractions? You flip one of them. Okay, the first one stays the same. Remember this? Okay, first one stays the same. The divide changes into a times sign, and then this one gets flipped. Okay, look at that. There's one numerator, there's one denominator. I highly recommend when you're doing these problems that you put parentheses around the quantities. Okay, can I cancel an x and an x? No, you can't. This is a whole quantity. Either you cancel all of him or you leave him alone, but you can't slice and dice just because you see things. Quantities have to stay like they are. Okay, and how do you multiply fractions? You just multiply across the top. Okay, and then you multiply across the bottom. Remember how I said I'm going to leave this in factored form? I'm going to put the x first so we don't lose him, and then x plus 2. Okay, I leave it in factored form so it makes the domain easier. So the domain is all reals. Okay, once upon a time, the domain for f was, don't use negative 2. All right, so I'm never going to suddenly be able to use negative 2. F didn't allow it before. You can't start using it now. G said you're not allowed to use a 1. Okay, we still have to listen to G. Did anything else happen here? Okay, I have negative 2 and I have 1. Right here, look what happened. Look what happened when it flipped. Somebody went into the denominator. Okay, and now I have a third restriction. Okay, x cannot equal 0. Okay, and that one got added because something went into the denominator. So you should look in the beginning, you should look in the middle, you should also look at the end to see if anything got added. Remember, when you do the divides, you might have another restriction that gets added. Okay, so just be super careful. All right, what else do we have? More operations. Okay, here's an f of x, and here's a g of x. Okay, so I'm going to write the domains. I like to do that. The domain for f is all reals. The domain for g is, also all reals. Okay, so they want me to do f minus g of x. All right, we just have to be careful here that we distribute that minus sign. So I'm going to write f of x with some parentheses. There's the f function minus the g function, 4x squared plus 1. And when you're subtracting a function, you have to subtract all of those terms. Minus, minus. Okay, so that's going to give us 2x cubed plus 3 minus 4x squared minus 1. Okay, so what does f minus g of x make? I'm going to rearrange into descending order here. 2x cubed minus 4x squared plus 2. Okay, go ahead and label which function you made. I made the f minus g of x. Okay, so let's go ahead and put a little note here. Make sure you label your answers. Okay, don't just do a bunch of work operations and make an equation without telling people what equation you made. This is the f minus g equation. Okay, and then how about the domain? F allowed all reals, G allowed any real number. Adding them together, no new restrictions appeared. Okay. Oh, so this one's easy. The domain is all reals. Okay. When it's reals and reals, unless you added someone to the denominator, it's going to be all reals. Okay. Let's take a look at one that has a radical sign. So when you're doing the domain, okay, you just care about the expression under the radical. Under a radical says be greater than or equal to 0. I don't care about the 3. He's not in the radical. So for f, the domain is x's have to be greater than or equal to 2. And g's domain is all reals. Okay. And they want me to calculate f minus g of x. Okay, so the f of x is the radical, x minus 2 plus 3. There's the f function. And then we have to subtract the g function. I'm going to go ahead and use parentheses again, just to make sure that all of g gets subtracted, meaning I distribute the negative. Okay, so let's make sure we label. The f minus g of x function is the square root of x minus 2. And then maybe I'll add the like terms at the same time. Oh, I'll just write another step. Plus 3 minus 2x minus 7. And here we go. The radical is going to stay by itself. And then I'll write the minus 2x term and then minus the 4. Can these terms be added? No. Okay, they're under a radical and they're not. So you just leave it separate like that. You just leave it separate. You can't combine numbers that are in radicals with numbers that aren't in radicals. How about the domain? Okay, the domain for f said be more than or equal to 2. Okay, so he's not going to allow negatives to go in. G will accept all reals. And I notice here that they are combined. So there's no new restrictions that got added. Which domain answer am I going to say? I can't say use all reals and then only use numbers more than 2. So I'm going to pick the one that's more restrictive. F likes numbers that are 2, 3, 4. Will G accept numbers 2, 3, 4? Yeah, G will accept everybody. But I can't say all reals because F won't work. So I have to go with x's that are greater than or equal to 2. Okay, we have to use the more restrictive one because this part of the function won't work if I use reals. I have to listen to the domain for f. Okay? All right. Ooh, another fraction one. All right, so we've got f of x, g of x. Let's state the domains. So for f, whenever you see a denominator, the rule is denominators cannot equal 0. Cannot equal 0. Okay, so f, the domain for f is all reals except not the number, -7. And g is all reals except x cannot equal the number, move it over, -10 divided by 5, negative 2. Okay, so f will work with all numbers, just not negative 7. G will allow all numbers except the number negative 2. Okay, and we want to make sure that both functions are working. To do multiplication, we're going to write the f function, okay, times the g function. Okay, and remember what I said about when you have fractions and quantities? I highly recommend going ahead and putting parentheses around them. Okay. Now I'm not going to go ahead and distribute. I don't need to add any like terms like I did. The question is, can I cancel any of these? Can I cancel an x with an x? No, you either cancel the whole quantity or you leave it alone. He's a whole quantity. Can't just chop off a piece of him. No slicing and dicing. Can I factor though? Can I factor something out of here? I'm noticing they both have a 2. So what I'm going to do is factor a 2 out, leaving me with the quantity x plus 2. Okay, so now that 2 might cancel, or this quantity might cancel. Okay, so I'm just going to go ahead and write all the factors in the numerator. Okay, why do you factor? Factor to look for canceling. So you look for common factors to see if anything cancels. In the denominator, x plus 7 cannot be factored. How about 5x plus 10? Let's factor out the number 5. I'm going to put it out in front, okay? The constants, or the coefficients that can kind of be by themselves, put them in front so we don't lose them. And I get x plus 2. Okay. Oh, look at that. I see common factors. Okay, so now these can cancel away. They can. The whole thing or nothing. Okay, if you have the entire quantity in the numerator and you do in the denominator, it can cancel out. Can you cancel numerator with numerator? No, that's not how it works. What you do to the top, you do to the bottom. So in the numerator, I have 2 times the quantity x minus 3. I've got that 5 times the quantity x plus 7. Okay, nice, very cleaned up. And now let's talk domain. Okay, it's all reals except, all right, f did not allow negative 7. Okay, so we still cannot use negative 7. Okay, g said do not use negative 2, but negative 2 got canceled out. Do you think it would be okay to start using it? No. Okay, if you weren't allowed to use it in the beginning, you're not allowed to use it ever. Okay, x cannot equal negative 2. You cannot do that. Is there any more restrictions? Let's look everywhere in the middle. I've got negative 7. I've got negative 2. Did you get them all? Okay, remember, look everywhere. Beginning, middle, and end. But what if I cancel it out? You still have to list it. You can't just suddenly start using negative 2. Okay? All right, I think we've got one more. We've got a divide one. Okay, so we're going to take f. Oh, let's do the domain. The domain for f. Okay, when you are a radical, you have to be greater than or equal to 0. So the x's have to be more than or equal to a 2. And g, since you're in the denominator there, cannot equal 0. Okay, so all reals except not 0. All right, let's go ahead and write f divided by g. F divided by g. Remember, when you have this divide sign, let's see, here's radical, x minus 2. Should I put a big divide sign and then a fraction down here? I don't really want to make a triple-decker fraction. Remember how to go old school? Divided by f divided by, and then I'll write the g function. Good. Okay, so that's how you handle dividing fractions. And then remember from grade school, the divide gets changed to multiply, and then this second fraction you reciprocate. Flip it upside down. Okay, let's talk about how we're going to write this nice and cleanly. Okay, so I've got f divided by g of x. Don't forget to label. That x is not under the radical. Do you think I should just slip it under there? No, he's not in the radical. I'm going to put him in front of the radical. Anytime you have a loose variable or a coefficient, put it in front so that people can clearly see x is not in the radical. And then when you're multiplying, this is kind of like over 1. Numerator times numerator, denominator times denominator. Okay? Can these x's cancel? No, because that's part of a quantity. Okay, good. All right, let's go ahead and state the domain. Okay. So looking back at things, f said be greater than or equal to 2. All right, so I know I have to do that. Okay, so I have to be greater than or equal to 2. Okay, G says, please do not use the number 0. Do not use the number 0. Sometimes a number line helps people understand this. So if I'm looking at a number line, F wants me to take the number 2 and use all the numbers greater. Okay, I will. I'll use 2, 3, 4, 5, 6, all those. F says, please don't use 0. Well, 0's over here. Okay, don't worry, G. I'm not. Okay, I'm not going to use 0. I'm using the numbers more than 2. So I'm not going to state that because it would be redundant. You don't need to say don't use 0. I don't plan on it. Okay, how about anywhere else? Right here, when we divided and then we reciprocated, look what happened. Somebody joined the denominator. Okay, so this says x. X's cannot equal 7. But do I have to write that, or is that redundant? Do I have to say, oh, don't use a 7? I think I do. 3, 4, 5, 6. Okay, so 7's right here. I have to take 7 out of the mix. And, comma, and you're not allowed to use a 7. Okay, this one here is really tricky. You have to look at the beginning, the middle, and the end. Okay? So I hope you can perform different operations with the functions, okay? And I hope that you can find the domain, okay, by looking at the beginning, the middle, okay, and at the end. And don't be redundant. Thanks, guys.